All right.
Just let me know when I can go.
Yeah, sure, Jay. We're logged on, so hi everybody that's out there, and Jay, yeah, we'll let you kick things off.
Okay. Well, good morning, everyone, and welcome to the April Reliability Forum. Today's forum is hosted by UE Systems. We have 18 plants with ultrasonic inspection instruments. That's about 40% of our manufacturing plants, and another 6 have the ultrasonic assisted lubrication equipment. And so I thought a forum focusing on ultrasonics as a form of condition-based maintenance was a worthwhile venture. Maureen Gribble, the Director of Marketing at UE Systems, will be the moderator today, and Doug Waetjen, the Vice President of Global Operations, will run the presentation. I have known Maureen for probably the last 10 years, working with her on SMRP's annual conference committee, and so I reached out to her and asked her to host today's forum, which she gladly accepted, and so here we are today with the forum. I'll now turn the forum over to you, Maureen, and sit back and enjoy the presentation. Maureen, the meeting is now in your hands. Thank
All
you.
right, great. Well, hi everybody that's logged on. Thanks, Jay, for this opportunity. We're excited to speak with you all today. Just wanted to do a couple housekeeping things before we have Doug take it over. But just so you guys know, we are recording this, so I know you've got some colleagues that couldn't attend, or maybe you'll want to take a look at this a little bit later. But so we're recording it, and I'll get the website link where we'll have it hosted to Jay so he can share that out with you guys. Also, just wanted to let you know that you do have the ability to ask questions. You can type those into the little questions box on the right-hand side of your screen. It should be pretty easy to find that. So feel free to type those in as Doug is going throughout his presentation. Certainly, if it's something pretty pertinent to what he's about to move off of, I'll chime in and get that asked, or of course we'll have some time at the end as well. So just keep that in mind. And with that, I'll let Doug now get started.
Thank you, Maureen. Thanks, Jay, and thanks everybody for spending some time with us today. You can imagine we're always excited to talk about our technology, how it fits in with some of the other initiatives and some of the things that you folks are doing at all your facilities. And just to reiterate, like Maureen said, please ask questions, type them in. If you're more comfortable, just drop us an email. You can drop me an email, or you can drop it to info@uesystems.com. Either way, we'd certainly love to engage with anybody who's on this presentation and talk to you some more about the technology and, again, how it fits in with what you folks are doing at your individual plants. Just real quick, a little bit about our company. Been around forever. Founded back in 1973. Our headquarters and manufacturing and engineering and basically everything is here in Elmsford, New York, which is just a stone's throw from New York City. We're about 20 miles north of Manhattan, right on the beautiful Hudson River. All our instruments come with a 5-year warranty. I know some of your plants are using our equipment and have probably gotten the benefit of our regional managers coming out and doing an equipment orientation when you get one of our units. Certainly those guys are also available for refresher training. I know many times you have new hires that come on board into the maintenance reliability department, new technicians. Please reach out to us. I mean, that's one of the things that we sort of pride ourselves on and that we love to do is we love to make our customers into really good users of ultrasound. So anytime you have questions or you want to get one of our guys out there, please let us know, and we really try to accommodate that. We're big believers in training, and I'll talk some more about that at the end of the presentation. We offer certification courses all over the world, all over the country, so you can sort of bet that there's one somewhere near your plant that you could attend if you have people who want to dig in and get certified in ultrasound for level 1 and level 2. We also do a bunch of on-site training as well, where we come to your facility. And then we're really looking forward to next month, a couple of weeks from now actually, our 12th annual Ultrasound World and our 3rd annual Reliable Asset World Conference. And that's May 10 through 13 in Clearwater Beach, Florida. We're pretty excited to get that to get that kicked off again this year. We've got great attendance, some great presentations. Anybody with any questions, please, please ask us about that. We can get you some additional information. Okay, our global footprint. We've got 14 offices throughout the U.S. And 3 trainers in the U.S., full-time trainers. We've got 2 offices up in Canada, several people down in Monterrey, Mexico. Got offices in Europe, sort of spread out, Middle East, Cairo, Egypt, and in Asia, we've got Hyderabad, India, and Hong Kong. So for any of your international facilities, we can certainly support that and support any of your ultrasound programs there. So what's ultrasound? I'm going to jump right into it. Ultrasound really is used for sort of 3 distinct application groups. Leak detection, whether we're talking about your compressed air system in your plant or compressed gases, we can use ultrasound to detect those types of leaks. We use it on steam traps. We use it on valves for determining internal pass-through on a valve or leak-through on a steam trap. So from an energy standpoint, it sort of remains one of the top technologies for those types of applications. It's also a great way to justify your program. So if you're struggling in many cases with how do we get a condition monitoring program going on our bearings and our rotating assets, how do we invest in the equipment and the training? One of the ways to do that is through the energy savings you can realize by doing an air survey or a steam trap survey at your site. So a lot of people take advantage of that opportunity to go out and show some hard savings. And then once they've already realized that return on investment through the energy side of things, they've got a piece of gear that they can expand out into doing condition monitoring on rotating equipment or electrical inspection on their electrical distribution system in their plant. So they're the 3 main things we do. On the bearing side of things, condition monitoring side, it sort of breaks down into 2 sides. One is on the bearings, and the other side is shifting over from more of a time-based lubrication program in condition-based lubrication program. I'm going to talk about that as we move forward here in the next couple of minutes and why that's important. So that's sort of where ultrasound's used and what it does. Very simply, ultrasound instruments, for those who aren't familiar, it's a listening device. It's a miracle ear. Lets us hear a high frequency range of sounds that we're not going to be able to hear with our ears. And that gives us some advantages. We're able to use it in what you may perceive as a very noisy environment in your plant. That noisy environment is noisy to your ears in the low frequency ranges. The high frequency ranges, because of a lot of their characteristics, make it usable in those noisy environments for locating the source of leaks, locating bad bearings, locating traps. So it's really an interesting technology in that respect, and it takes some getting used to. For those of you who currently use the technology, I'm sure you'll understand what I'm talking about when you're out in the plant. It's amazing what you're able to hear just in those high frequency ranges. And essentially the instruments take that high frequency sound, they translate that high frequency sound into something audible that we can hear through a headset, but also it translates those high frequency sounds into a dB that we can measure, and that dB measurement is either used to evaluate things like bearing condition over time where we trend it, or the dBs can also be used to put a cost to a specific leak. So it's nice to be able to not only hear the sounds when you're out troubleshooting or trending, but actually put a number to it and assign a value that's trendable and trackable. And then the third thing it does when it translates that high frequency sound is with some of our instruments, it gives us the ability to record those sounds. And that then gives us the ability to do some further analysis. Again, I'll talk about that in just a few minutes. But essentially, it's a high frequency listening device. It only hears sound. It doesn't emit anything. And it lets us listen to a whole range that we can't hear with our ears. The range that we're really listening to is 20 kilohertz to 100 kilohertz. Human beings hear about 16 kilohertz. So it's well above what we can hear people. And again, I mentioned we measure in decibels. Ultrasound is really directional, so it lets us very quickly and very easily pinpoint the source of problems. And we look at two things. We either look at turbulence, which is a source of ultrasound. Typically, turbulence would be from a pressure or a vacuum leak, or turbulence can be created by electrical discharge. And we also look at friction, and that's typically what we're looking at when we talk about condition monitoring of bearings and rotating assets. It's also what we would look at from a lubrication standpoint. You know, too much friction, too little friction, and that lets us make better decisions when we know how much is there. So we can hear that these sounds above any normal plant background noise, which gives it a decided advantage to using a stethoscope or to using our ears. I'm sure many of you have seen this curve in varying configurations. I personally really like this version of it because it adds in the eye. For those of you who are not familiar with this, the P to F curve is really just a visual representation that lets you look at the point that a failure can be detected in an asset to the point where you have full functional failure, and some typical technologies and where they fall on the timeline of when that failure can be detected. So you sort of take two of the technologies up at the top here, the ultrasound and the vibration, which are very early on in the process of a failure, from when you can find it to when it fully functionally fails, all the way down to you see, once something is smoking or it's hot to the touch or you hear it audibly, that's sort of way down on the curve, and that's where you've already got faults. What I really like about this curve, and I like to bring this up whenever I talk about any condition monitoring technologies, is while we can detect failures fairly early using ultrasound and vibration, don't become very great failure finders. And I hear this all the time. I hear people say, we've got a great vibration program, or we've got a great ultrasound program. We find all these failures. Every month our guys are coming up with great finds. Well, okay, that's good that you found them before you were down here in the fault domain. You sort of found them early, but now what do you do with that information? That's the key to the whole thing. It's great to be able to identify problems, but once you've identified them, you got to really go back into this proactive domain, and the eye really is sort of from installation to the point of where a failure can be detected, and you've got to make changes to what you do in that proactive domain. And I'll give a couple examples from an ultrasound standpoint. If you're identifying leaks, and this is sort of not a typical analogy people will use, but I like it. If you're identifying leaks out there and you're addressing those and repairing those leaks and documenting the energy you saved by repairing those leaks, just take compressed air as one example, it's not enough to just go find them and fix them. What you really need to look at then is the leaks you did find. Was there a way to prevent those happening in the first place? In other words, could you go into that proactive domain and could you think to yourself, well, I've got the ability to go buy a higher quality quick disconnect, or I've got the ability when I install part of my compressed air system to use hard piping rather than run hundreds of yards of flexible piping, which is more, or flexible hose, which is more likely to spring a leak. So there's things that you need to think about, and that information that these condition monitoring technologies give you when you find these problems is just the tip of the iceberg. You need to go back and think, okay, we found these failures. Now, what was the original cause of these failures? Was there a way we could prevent them? Another example would be, using ultrasound to do condition-based lubrication. If you're continually out lubricating bearings and then you take it a step further and start to find a lot of failures, maybe the reason these failures are taking place is something back in that proactive domain that you should be looking at. Are they storing the grease in a clean, dry environment? Are they using the correct grease? Are the grease guns they're using calibrated? So when you're putting a certain number of pumps in, is it really the correct amount going in based on what you have set up? So again, I like the PF curve. I like the I to PF curve, but I want everybody to use this as sort of food for thought, that just using these technologies and just finding problems is not really the answer. It turns you into a really good failure finder. But unless you take that information and apply it to the practices and that you're doing before you ever install equipment or as you install equipment, you're not really going to improve your reliability in your plant. You really need to be taking that information and putting it to good use. Some typical applications, again, I mentioned this, compressed air and gas leak detection. Anything under pressure will create turbulence, and ultrasound can detect the source of that turbulence very quickly and very accurately. We can detect vacuum leaks, in other words, leakage that's being pulled in, very easy. And a non-intrusive method for leak detection. In other words, you don't need to use any kind of surfactant or fluid. It's strictly based on hearing the turbulence at the leak site. Steam leaks out to atmosphere, and electrical inspection, whether that be outside in your substation, whether that be in switchgear and closed switchgear and motor control centers in your plant. Ultrasound is a quick, accurate way to determine if you have corona tracking and arcing. Some typical structure-borne applications, the ones I just talked about up here incidentally, were all what we call airborne applications. So we use a scanning module on one of the ultrasonic tools, and these are sounds that travel through the air out into atmosphere, and we can hear them. We switch gears and talk a little about structure-borne applications. And we've got bearings, we've got motors, gearboxes. We can listen to pumps for cavitation, steam traps, internal operation of a trap, whether it's functioning properly, whether it's leaking. There's all kinds of things we can determine to make sure a trap is functioning correctly. And a trap that's leaking or passing live steam is going to be a huge energy waste, but can also create a lot of safety concerns and safety conditions. We can listen internally to valves, see if valves are leaking through. Again, another great application for ultrasound. And lubrication, condition-based lubrication, whether we're in the process now of trying to optimize time-based lubrication, where we're trying to determine the interval to go out and lubricate, or whether we're really moving into some best practices of condition-based lubrication, where we identify the need to lubricate rather than base it on time, base it on the condition of the asset, and then go out and make sure that we're not putting too much grease in. So again, some typical applications of ultrasound. I'm going to start and just talk a minute about energy conservation. Ultrasound is one of the primary tools in use in thousands of plants across the globe for compressed air. The source of that leak is that we hear, the source of the ultrasound is turbulence. So any pressure leaks are going to produce a tremendous amount of turbulence. We not only can locate those leaks, but because of the changes in the technology over the past 10, 15 years, we can actually take the dB that we are measuring from that leak, type in the pressure, and what our cost per kilowatt hour of electricity is, and we can actually get a CFM leakage and put $1 onto those individual leaks. To take it even a step further, we're now able to, by fixing those leaks, we can document the greenhouse gas emission reduction. So in the software that we have with our instruments, it actually lets us do that. I'll show you an example here in a second. But very easy application to go and pinpoint the leaks. I'm going to try to play this. The video will play. I'm going to try to play the sound and just put my mic real close to it. If one of you, Maureen maybe, or Jay, could just let me know if they can actually hear this, and then I'll know for future sound files that I'd like to play. I'm not 100% sure this is going to work, but we'll give it a shot here. This video is of a gentleman actually using what we call the gross to fine method, where he starts out a little farther away from the noise. He'll adjust his sensitivity down until he's able to pinpoint the source of the leak.
And we can hear it, Doug.
You can?
I mean, it's
Okay,
a little
good.
faint, but yes.
How about here?
It might be a little tough for them to hear it. I'm not getting too much, Doug. A little bit. At the beginning, it was better.
Okay. I've got to sort of I'm wearing a headphones, so I sort of have to bury the microphone down into my computer, and it causes my face to be pressed up against my screen to get close to the speaker, but we'll give it a shot for the next one. So anyway, as I said, the source of the ultrasound is that turbulence that's created at the leak site. So by doing a simple procedure and following a simple procedure with one of our ultrasonic pistols, you can pinpoint the source and then you can measure it. So if I move on to the next slide, it's just an example of what a report looks like. But we're able to actually we're actually able to, by repairing those leaks, document the CFM leakage and also the actual cost. If you look over all the way to the far right, it gives us the ability here also to mark down whether that leak was repaired, so we can track these over time. Oops, sorry. And then we can also trace the greenhouse gas emissions per each individual leak and a running total. So it's really a nice way to document. If you've got a green initiative, it's a nice way to document that you're not only saving the energy for the plant, but that you're helping the environment by reducing your greenhouse gas emissions. So that's all documented. The greenhouse gas emission tables are in there, and we went to each individual Department of Energy for each state. And we're able to link and actually have a patent on this. We're able to link the individual greenhouse gas emissions per kilowatt hour in each individual state in the U.S. We've also got these tables for Europe. So kind of a cool little extra deal we can offer inside of your leak detection program. We've also got something we're really excited about. We've got a new app. So if anybody's interested in this, go, and if you have an Apple phone, we're currently working on getting it for Android, which should be relatively soon, hopefully in the next month or two. But the one is available now in the App Store. So you can actually go out with your ultrasonic detector and with an iPhone or with an iPad and download this app off of the iTunes store. Just you can punch in compressed air leak survey app. I think it comes up under UE Systems as well, but the easiest is leak survey app. And take photos, enter in what the dB level is from the ultrasonic detector, and then simply click Generate Report and email yourself a report similar to the one I just showed you back here. So it's kind of a nice, really portable, easy way to generate a nice leak report with all the costing information and everything you need to document the energy savings and the reduction in greenhouse gas emissions right there from your iPhone. So you don't even have to wait to get back to your office after you've done a leak survey. Kind of cool. Anybody who's interested in that, we'd love to get some feedback on how that works. So if anybody's using an iPhone and goes out downloads the app, please drop us an email and tell us what you like about it, tell us what you don't like about it. But again, this is brand new, only in the last month or two, and we're pretty excited about it. All right, I'm going to switch gears, move on, and talk a little bit about electrical inspection with ultrasound. It's become, over the last several years, a major application. Most people think of their electrical distribution system in their plant, or they think of their substation outside of their plant as a place where they're going to use infrared. But the interesting thing is if you look at different failure modes of electrical apparatus, there's a distinctive type of failure mode that infrared will detect, and there's a whole separate set of failure modes that ultrasound will detect. Infrared really is geared to pick up resistance-based failure modes, while ultrasound will pick up ionization-based failure modes. And there's plenty of examples and plenty of pieces of gear that you're really only doing half the job if you're relying 100% on infrared to find all the failure modes. So many companies and especially many service providers have actually started to employ ultrasound right hand in hand alongside of their the thermography program, and with great results. So we can use that on any voltage. It's not really voltage dependent. Primarily, people start out with ultrasound as a safety initiative. In other words, I'm sure you've heard, if you work around electricity, there's always the potential of an arc flash incident when you open enclosed cabinets or enclosed switchgear. Even when you're completely outfitted in the proper PPE, you may avoid the serious burns, but if you're involved in an arc flash incident, it could throw you across the room, and maybe the burns aren't your biggest problem, maybe breaking a shoulder, breaking an arm, or worse. So one of the things that a lot of service providers and a lot of individual plants and companies globally have started to implement is scanning enclosed switchgear with ultrasound, listening for any type of a problem. And typically on enclosed gear, what you end up hearing is tracking problems. And if that's heard, you don't want to open the cabinet to do the infrared inspection. You want to de-energize it, then open the cabinet and do a visual inspection to determine, what the source of that tracking is. So it's really a great way to keep electrical workers safe. You can see actually down the bottom, it's taken on so much momentum that they not only have now infrared windows to keep the cabinet closed, but there's ultrasound windows where you can listen internal to the cabinet and hear, tracking or arcing conditions if there's not an air gap. If you take a look at the top picture here, you can see most enclosed switchgear, there is an air gap around the door, or in some cases there's ventilation louvers, and you're able to actually hear the sound from what's going on inside of that cabinet. So again, as a safety precaution, before those cabinets ever get opened, many of the companies we work with on a regular basis have made that part of their electrical safety and infrared safety program. Scan it with ultrasound first before you ever open the cabinet. Some factors, some things to think about with electrical inspection. Obviously, safety is a real big one. Obviously prioritizing which equipment that you need to go out, and the way to do that is how likely is it to fail, the economics of a failure, and are you relying only on an annual infrared scan? I know many plants or companies use insurance companies to come out once a year and do infrared scans, but in between those inspections, what are you doing to ensure that your workers are safe and that you're not risking some type of an electrical catastrophe? So ultrasound really is a big sort of partner to the infrared industry in that way. Not to mention there's so many problems we can find with ultrasound on its own. So again, some best practices for electrical infrared scans, usually done by an outside service provider. I know some companies do it internally. which is great, but a lot of plants use it, and an outside contractor do it annually, semi-annually. In between those scans, you want to use some ultrasound to periodically listen if you've got problems. You can almost use it to then direct the infrared guys where to go do further inspection. Again, there's certain types of issues that you're going to pick up that you won't pick up with infrared, and vice versa. So some of these, some ionization issues, some intermittent, tracking and arcing problems don't really produce a lot of heat. So it's something you really want to pay close attention to. Just a couple quick sound files here I'll play for you, just so you have an idea of what I'm talking about. Corona, which is essentially just ionization of the air. The problem with that is, while there is such a thing as what we call nuisance corona, if you go out in your substation on a morning where there's a lot of dew in the air, you're probably going to hear a buzzing noise. That in itself isn't always, run for your life catastrophe. Problem is, if you've got a tremendous amount of corona, one of the byproducts of that, when you mix moisture and dirt or impurities or dust, which you typically have outside, it can produce nitric acid, which over time is going to break down, the insulation material. And then you've got a situation where that corona, left unchecked, can turn into something more severe, like tracking or like arcing. It also doesn't produce significant heat, so usually you're going to miss that with an infrared scan. So I'll see if you can hear this. I'm going to play this sound file. Just corona is a sort of a buzzing sound. I don't know if you can hear that very well, but it's a very consistent buzzing sound. And here's what we call a time waveform, basically a sound recording from that corona. And you can see here what you've got is very distinctive 60-cycle harmonics in the spectrum, but then there's a lot of noise, a lot of white noise in between those harmonics, and that's a very classic signature for corona. We've also got an entire library of sound files and typical examples, so it makes it real easy for when an instructor is out there and he hears something, he's not 100% sure what it is. You can certainly go to that sound library and say, well, this really looks a lot like corona. We've also got sort of the next level where corona left unchecked, you've got what's called tracking, which actually creates a low current pathway to ground. It's not actually failed yet, it's not arcing, but the failure can actually occur at any time. One of the telltale signs that you've got a tracking condition is this tremendous amount of amplitude change. It gets louder and softer, and you can actually hear what we call mini arcing, popping and cracking inside of there. So I'm going to play this sound file. Again, anybody who needs these wave files, let us know. I'll be happy to email you a folder with all the sound files in. I know that one's probably more difficult to pick out the anomaly there, but it's essentially, we look at three things with electrical inspection. We look at how much does the amplitude change. In other words, how much does it get louder, softer, louder, softer. We look at how often do you have little events or little pops and cracks. You can see here you've got a whole bunch of little peaks, which in a time waveform means that you had a little mini arc. And then when they happen, how long do they last? So you can see some of these are fatter than others. So it lasts a little longer as that current travels across a pathway. In other words, across an insulator, across a bladed connection inside of a switchgear cabinet. The severe condition that we detect is arcing. And again, you can see a big amplitude change, goes from soft to very loud to soft to loud. There's a lot of individual events going on. And in the case of arcing, and you can tell when tracking starts to get more severe, these events last a lot longer. They're a lot wider. If you remember it back here, there's a lot of events, but they they only last a split second, little pops and cracks. You start getting into a severe arcing condition, and failure is actually occurring, and you're going to get very dramatic changes in amplitude, but then also these events last a longer time. And I'll play that wave file. Now that is an extremely severe condition, so that's something, if you hear that or sounds similar to that coming from enclosed switchgear, if you hear that coming from your substation, failure is actually occurring, and not only is it dangerous, but you're risking, an explosion. You're risking, severe damage to the assets. So that's something that you want to shut something down, find somebody. That's sort of a code red when you hear that type of a sound, using ultrasound for electrical inspection. So I'm going to, again, shift over to another application. I want to talk a little bit about equipment reliability from a condition monitoring standpoint on our rotating assets in the plant. One of the things we do is we trend these decibel levels over time. We set up a program, you pick out which assets need to be on the route, and you go out and you test them, usually on a monthly basis, very similar to what you do with vibration analysis. Any increase in the dB level would indicate that some kind of a change has taken place. So what we like to do is we like to set up alarm levels, and I'll talk about the levels we use here in just a second. But from a trending standpoint, we want to watch what that asset does over time, and we want to make appropriate decisions based on what we see. Where ultrasound has proven itself to be extremely effective is on any slow speed equipment that you have. And I'll define slow speed as sort of anything below 300 RPM, but we can get all the way down to fractional RPM. We use ultrasound on drag line bearings in mines that are a quarter RPM. And really, you're just listening. You're not so much trending on those. You're just listening for any kind of a click or a pop as that goes around. But it's extremely effective on slow-speed equipment because of the quick acquisition time that we have. We can go out, listen, and record a sound file, or just listen and make a judgment call on something very quickly and very accurately. We also have a lot of companies using ultrasound as a sorting tool. In other words, if you've got thousands of assets, it can be a tremendous drain on resources and time to go out and do full-blown vibration analysis on every asset. So we've got a whole method and procedure for going out and just using ultrasound to sort, to pick out, have we seen any change from last month to this month? And if we haven't, things are running along smooth. There's no reason to do any further inspection on that equipment. If there is a change, then we want to record a wave file with ultrasound. We want to look at the wave file. Maybe we want to bring in our vibe guy and have a look at it as well to see what's caused the change. I mean, is the bearing entered a failure mode? Does it just need lubrication? There's all kinds of scenarios that can cause the decibels to go up. So we use it right hand in hand in many cases with somebody's vibration program. Some best practices on equipment reliability. Initial, in other words, baseline readings should always include a decibel and a sound file if your instrument has the ability to record sound files. Very, very important. Once that baseline's been established, then you can go along taking monthly readings and just record the decibels until you hit an alarm level. Once you've hit an alarm level, then you should record the decibels and the sound files again to see what's changed and do that comparison test from the initial baseline to the point where it's hit either a low alarm or a high alarm. Couple examples of bearings. A good bearing should sound nice and smooth, and you can see there's not really anything in this spectrum that stands out. It's essentially, they're within a certain parameter here, and it's just white noise. So a good bearing is going to sound nice and smooth. I'll hopefully be able to hear this.
Yeah, Doug, we're not really hearing anything right
No, nothing there.
now.
It's just it's a kind of a quiet, rushing sound, almost like running water. On this, you'll probably hear this is a little louder. On a bad bearing, you can actually see these fault frequencies that are related to each other. And if I turn this on, I don't know if you could hear that a little better. I don't know if you can hear that.
Not so much.
Yeah, unfortunately, there's not a great way to play these WAV files through a WebEx. But one of the things that jumps out at you on this is you can see these harmonics here, which are basically showing us that it's not just white noise on that bearing, that there's actually fault frequencies there. And we can measure and take a look at those fault frequencies with a cursor inside of the spectralizer software, and we can determine, is that an inner race defect, an outer race defect, ball pass, what exactly is going on there once we see that type of a spectrum. We can also determine, and this is a good segue right into the lubrication section, when we test bearings, if we're seeing an increase in decibels over time and the spectrum looks like this, it's just getting louder but no distinctive fault frequencies, that's a good confirmation that really all that's happening is the friction levels going up and that bearing needs to be lubricated. If the dBs go up and we see fault frequencies, that's telling us that while, yes, it may also need to be lubricated, lubrication probably isn't going to be enough. It's already past that point, and there's damage. There's microscopic damage to that bearing, and that's what the cause of those fault frequencies are. So we can do some further analysis by simply recording the sounds. So a little bit about lubrication. This has turned out to be something we never even imagined a few years ago when we first started down this path with our ultrasound assisted lubrication tools. We've got one tool we started out with was just a simple analog tool that once you identified the need to lubricate, it prevented the lube tech from going out and putting too much grease in. It let him listen to it. It let him look at LEDs and say, okay, it's had enough. This new unit on the right here you can see is a digital, so it actually lets us take that a step further and do some trending. It lets us track grease usage. In other words, how many pumps did we actually put in? So it lets us track the commodity cost of the grease. So it really lets us do a lot more than just prevent over lubrication. We see more and more the interest in shifting over from time-based, which is strictly going by manufacturer's recommendations, this many running hours, this many pumps of grease, and shifting that into several different types of programs. We can shift that into optimizing the time-based. In other words, let's figure out what the correct interval is and stick with that interval. Or we can take it even a step further and go all the way to condition-based. Let's only lubricate when we hit an alarm point that tells us it needs to be lubricated. Other than that, ignore it. So there's all kinds of methods behind this. It just really depends on your strategy. And again, you could start with time-based and just make sure you're not over-lubricating the bearings. You could then move into optimized time-based, where you're using ultrasound to determine the intervals. And sort of the end goal that a lot of people see now is get to the point where you're doing true condition-based. So, the majority of bearing failures are somehow related to lubrication. And that's not UE Systems saying that. That comes from hundreds of sources. Somewhere over half, 60% or so, of premature bearing failures are somehow lubrication related. So the traditional lubrication program has always been time-based. Depending on the type of bearing you use, the manufacturer says, put this many shots of grease after this many running hours. Well, they really have no way to know the exact operating parameters that you're using those bearings in. They may know which motor it's in and what the load is, but all the other operating parameters they don't know. So it's really just an educated guess. And that's how they determine how much grease gets applied. The other problem that we always see is how many people actually have calibrated grease guns. So you could take the manufacturer's recommendation when he says put 10 shots of grease in after 2,500 running hours, but how do you know how much grease 10 shots represents if your grease gun isn't calibrated? So there's all kinds of problems behind the traditional sort of time-based program. We've sort of put a 1-2 punch to it, and we've been able to realize a tremendous amount of success where we'll identify which bearings need to be lubricated through our regular condition monitoring route, and then we'll optimize the procedure for lubricating that bearing by going out with one of our ultrasonic detectors that mounts right on the grease gun to ensure that you're not putting too much in. So it's a real-time lubrication process where this one needs it, this is how much we're going to put in, no more, and then taking it even a step further to some of the digital grease caddy instruments, we're able to actually track, okay, how much did we put in and how much did the PM call for, and the difference is what really the commodity savings is on how much lube you didn't put into that bearing. And the side benefit to that is if you'd put in how much the time-based PM said to put in, you would have over-lubricated it and probably failed the bearing. So really something interesting and something to take a real hard look at is these lubrication programs. And again, the source of the ultrasound in these lubrication applications is friction. As the lubrication starts to break down, the friction goes up, causing the dB levels to go up. And we can see that through our monthly condition monitoring. Again, I just talked about the two different types of grease caddies out there. It lets you know when we've applied enough, when or if we've already started to over-lubricate. And if there's anything else wrong with the bearing, we can actually look at those sound files and see if we've got fault frequencies. If a bearing needs grease, the dB will start to go down as that lubricant's applied. If the bearing's already over-lubricated, then dB will immediately start increasing. So if there's no change, you really don't need to do anything. Maybe hearing or you're still getting an increase, it could be that the bearing's actually entered a failure mode. So there's sort of three distinctive things here. I'm not going to play these files because we're having difficulty hearing them, but this is essentially a visual representation of what you would hear. So, and this is actually a real-time time waveform that was recorded while greasing. So before lubrication, here was the sound level. Soon as that grease hits the wear surface, you see that sound level drops down immediately. And that's your indicator, both audibly and visually. If you're using one of the ultra probes, you'll either see the spectrum on the back of or the time waveform on the back of the 15,000, or you'll see the dBs drop on the digital grease caddy. So you can see it's a very abrupt, dramatic change from when it needs lubrication to when that lubrication hits the wear surface. Just another example here. And in this case, I can't play the sound file, but as that grease is applied, the sound does get quieter, but there's probably also a bearing fault here because you're not really getting as smooth a transition as you were here. Here, the grease is going to make it quieter temporarily, but then the sound will probably jump back up because really what's causing it are these harmonics and that the bearing fault. So that bearing's already too late. And here's a really good example that we were able to experiment with, where here's before lubrication. They lubricated it until the sound level dropped down, and then they just kept over lubricating, or kept lubricating it until they significantly over lubricated that bearing. So you can see it loud, gets real nice and quiet, and the more grease they put in, the more they build up that internal pressure, and essentially by over lubricating it, you're going to end up causing a failure. So you can see the sound just dramatically jumps back up here. And again, anybody who wants copies of this or is interested in getting these sound recordings, please let me know. I'd be more than happy to send these out to you. All right, just a couple examples, and I'm winding it down here. I know we're getting close to the time. Reporting and documentation. The software that you can use with these ultrasonic detectors is really user-friendly, really easy. You can set up routes. You can do monthly trending. You can see here we're trending this over time. Here it hit a low alarm point. It kept going. Here it hit a high alarm. And we can also put images in. We can look at trend charts. So there's all kinds of different reports we can generate. Here you can see it's what we call a 4-image report. Here we actually imported an infrared image of that bearing as further documentation. Here's a digital photograph to document. So if you attach this to a work order, the person knows exactly where to go out and make the repairs. Here's a copy of several months worth of spectrums, and you can see there's 3 different here, and then there's the 4th one, which we can overlay onto that spectrum, and you can see here's very distinctive fault frequencies. So a lot of ways to document the different conditions that you're running up against with your ultrasound program. There's another just shot of that FFT overlay where you can put 4 different images or sound files and compare the same point over time. We've also got some remote monitoring options. Again, I see more and more as I go into plants that there's a lot more guarding and a lot more shielding going on. And one of the things that happens is we hear from the techs out there. They're like, well, we can't really run our route on that line anymore because they put guards over all the motors. We can't get in there to test with ultrasound. Well, we've got what we call a remote access sensor, which lets you mount a sensor internal, and as you can see here by this right-hand picture, run the cable out to a junction box and simply just go take your ultra probe up and hook it into the cable that's coming out and still keep that on your route. It's no different than actually touching the motor with the magnetic mount. So they can be run 25 or 50 feet with no loss of signal. We've got some permanent sensing application that we can address with UltraTech 750, and we've even got some cabinet monitoring sensors that permanently stay inside of enclosed switchgear and identify when there's some tracking or arcing conditions. So there's plenty of remote options in this changing world we live in, with more emphasis on safety, more emphasis on guards and shields. There's always a workaround and the ability to go out and monitor safely. Some training courses we offer, and then we'll get to some questions. Level 1 ultrasound, level 2 ultrasound. We have a 2.5-day technology implementation course. And again, I talked earlier, check our website out. I mean, the Ultrasound World, Reliable Asset World are a great resource if you're really looking to pump up your ultrasound program. There's guys there who have done that, been there. They really know how to get a program going and keep it going. And of course, we do our monthly webinars. So just in conclusion, and we'll get to some questions, very versatile technology, does a lot of different things inside of the plant. Pretty much use them in any environment, doesn't really matter how noisy it is. We're not the only game in town, and we know that. We don't even profess to be the save-all, silver bullet to your maintenance and reliability needs. What we do know is we fit in really well with a lot of the other PDM technologies. And if you look at it from a big toolbox concept, we're certainly a flexible, easy-to-use tool that can help anything else you're doing for your initiatives. And a really quick ROI. I mean, ultrasound's still one of the most cost-effective technologies out there. So,
All right.
questions?
Yeah, so we did have a couple come in, so we'll try and get as many of these answered in this last 5 minutes. Um, for the talking about the grease caddy, someone was wondering if the 201, if it's possible to trend with that piece of equipment.
Not really. It was never designed for that, and it's not really accurate. I know there's people who say, well, you've got LEDs on the back, but the LEDs are not really a good way to trend. You really need that decibel number. It's kind of grossly inaccurate just using those LEDs, just the lights going up and down. Lubrication has become so much more of a precision game, and that was really the catalyst for us actually designing and introducing the digital grease caddy. If you're going to trend, I'd rather see somebody actually take like an UltraProbe 9000 out there that reads in dBs before I'd want them to try to trend with a grease caddy. The 201, one purpose. It's like a Phillips head screwdriver. The UltraProbe 201 prevents you from over lubricating by letting you see and hear when the grease hits the wear surface, stop pumping grease into it. That's what it does. It's a Phillips head screwdriver. Whereas the 401's more, Swiss Army knife.
All right. Talking about noisy areas. So someone was wondering if in one of those noisy high vibration areas, does that affect your readings if you're using a contact sensor?
Not really. It really has very little impact at all. Especially we've got the magnetic mounts that we use with the tools to go out and run our routes with, and they're coated in foam. I mean, you'd have trouble getting any background noise on those. I mean, I'm not saying it's impossible. Somebody's banging on a coupling with a hammer as you're trying to test the motor bearings, you might hear it. But that said, just normal plant background noise, no, it's not going to have any effect.
All right. And then are there any options for continuous ultrasonic monitoring / trending on bearings so that alarms can be set up as levels increase? I think you touched a little bit on that.
Yeah, that's right. Right there. We can do it either with the switch box, and you can use your standard handheld tool, or you could switch up and go into more of a situation where you're setting it up with an UltraTrack 750. But typically, the online monitoring we're doing is still a monthly trending type of thing.
Awesome. And just real quick, if anybody has any other questions, our website, uesystems.com, if you go to the training section, we've got a section within that called On-Demand Education. And in there, you'll find we put the recordings of all the webinars we do, and we do them at least once a month, if not more, if we've got kind of a special topic going on. So, if any of these sections were of interest to you that you'd want to dive further into, the lubrication, the energy savings, even if you're using our equipment and you want to dive in further on the reporting and the software, we've got webinars recorded on all of those topics, and you can find them really easily. So, during lunch breaks or when you've got free 45 minutes or so, you can go in and watch any of those and see a little more in depth on the different topics that might have been of interest to you that Doug had to kind of, give an overview of. So definitely check that out. And if there's topics that you don't see on there, we're always looking for good ideas for topics to do our webinars on. So, feel free to toss an idea to us that you'd like to see, and we'll go track down the right person to present on that. So no worries there. And also wanted to make sure you guys knew, and I think a couple of you guys have actually signed up for it already. We just launched our online compressed air survey course, which we're really excited about. So again, it's a class that we used to teach in person, and we might still do some in-person trainings on it. It's a one-day thing, but we've compressed it into 6 online modules that you can kind of take at your pace, on your schedule, whenever, wherever, kind of a thing. So, if that's something that you're interested in, definitely check that out. And that's, again, you can find that on the training section of our website. So, Jay, did you want to add anything last minute? No other questions?
No, well, I do. I just, and again, I'll close everything out. And again, thank you, Doug and Maureen. It was a great topic and a great presentation. I appreciate your time and effort both preparing and presenting the information. I think it was a worthwhile investment of my time listening to the presentation. I learned a few little things that I hadn't known before, so hopefully everybody else on the call got something else out of it. Again, I just want to remind everyone that the New Systems website does have some great resources for you, either for ongoing training or to maybe address some problems that you're having with your equipment to see how their equipment will help you identify those problems. So I use it quite a bit, and I would encourage everyone on the call to use it as you need it. I just want to again thank you for that.